Okay, let's try this one. Number 2, let's go with calcium carbonate. And already you see an ATE ending, so hopefully you know where you are. Now we get calcium oxide plus carbon dioxide. And I'm a little bit off of the screen. Carbon dioxide. Okay, there you go, my friends. Take it apart. Get their proper formulas or symbols. Check oxidation numbers. Check to see if you have some of these that are using the di-tri-tetra system, because you've got two nonmetals together. And then balance the left side and the right side. Okay, I'll give you about 4 minutes. Go. Okay, I'm going to start right over here. And the first thing I have to do is take this thing apart. Calcium symbol is Ca. Now I need carbonate. Here we go again. ATE, you know where you are. It's on here. And you simply have to search. And there it is. Carbonate, there is the formula, and there's the oxidation number. So it looks like carbonate is CO3. And then the oxidation numbers, you know you have to do that unless it's two nonmetals together. According to the table, that's a -2. And according to your periodic table, that's a +2. And that is perfect because those two will add up to 0. All right, so calcium carbonate is done. Now, let's check the product side. Here we go again. Calcium symbol is Ca. Okay, now carbonate's gone. We've got oxide, which is oxygen. No, it's not alone. Yeah, it's one of those magnificent 7, but it's not alone. So what we do is we go back to what we learned about topic number 5. We got to check some oxidation numbers. And look at that. That is perfect. They'll equal 0. That's done. Now let's take care of this. Oh, did you guys see it? Look right here. There's the weird di-tri-tetra combination that they use when two non-metals are together. So now we're going back to topic number 10, but we're using this system. And as you review your topic 10, we don't have to have oxidation numbers. All we have to do is use the prefix system to tell us how many of each we have. So now the game is just slightly different, but a lot easier. We don't have any math. So now, soon as I see that, I'm going to pause and I'm going to change the way I change this to a formula. So now watch what I'm going to do. Yes, the symbol for carbon is C. I can tell that it is oxide, which is oxygen. And now I have to look for these prefixes. Do you see a prefix for the guy that's in front? Do you see like a di-tri-tetra? No, there's nothing in front. So that means that there is only one carbon in front. Do you have to write the 1? No. So I'm going to get rid of that. But nothing in front means one carbon and that's it. Ah, there we go. I need to keep track of this. This di means 2, so that has to go here. See how there's no oxidation numbers? Now it's simply a prefix game that will inform us of how many we have of each, which is a lot easier. You got it made right there. Okay, so this is correct. This is correct. A little different system, but the formula for carbon dioxide, which you have seen forever, you now know is correct. Let me move this up a little bit to get it out of the way. And now it's time to balance. Let's get the left and the right side the same. Let me get rid of this. Okay, so take them one at a time. Looks like I have one Ca here and one Ca here. Go inside and grab that carbon. Looks like I have one carbon here and I have one over here. That's good. And now these oxygens, look at this. Looks like only 3 on the left. Let's now check out the right. Looks like I've got 2 here, plus only 1 here, and that, my friends, equals 3, and look at that. Balanced. Done. Good one. Now, the reason why I gave you this is because you have one of these on your assessment where you have to use the prefix system because we have 2 nonmetals sharing electrons to obtain an octet to form a molecule. Okay, so be ready for that. Okay, let's take a look. Questions on this one, especially on that part? All right, let's take a look at number 3. Again, just get as far as you can on these things. Hopefully you go all the way and get it correct. If you get stuck, then just stop, wait for me, and then when I review it, find out what went wrong. Number 3. Let's try, hey, a nice small one. Look at this one. Zinc plus oxygen makes zinc oxide. Oh, this one is tiny. This is a quick one. Let me get some more space here. Sorry, I didn't mean to put that together too close. All right, come on, man. You can do this. Take this apart. Change these into the proper symbols and formulas. Check oxidation numbers. Check to see if there's a mon, di, tri, tetra system. Check the Roman numerals, which are not in this one. And let's go. Get this thing balanced. Okay, I'll give you 3 minutes. Go. You got it. Okay, I'm going to start right here. I'm going to take apart zinc. Yeah, I'll look up zinc on the table, and boom, there he is. There's his symbol. Oop, I'm going to stop right there. Is zinc alone? Yes. Is zinc a Hofbrinkel? No. Okay, I'm going to move on. Oxygen. And I'm going to stop right there because something's not right. Is it alone? Yes. Is oxygen a Hofbrinkel? Yes. There's your 2 yeses. You have to put the 2 there because this non-metal is pulling your topic number 8, sharing electrons to obtain that lovely octet, forming a double bond. Hey, let's go, product side. Zinc. There's the symbol. Oxygen, there's the symbol. Oh, hey, I'm putting 2 guys together. You put 2 guys together, you should know what to do by now. Check some oxidation numbers and look at that. That is perfect. So that's done. Correct, correct, correct. I'm going to balance the left side and the right side. 1 Zn here, 1 here. 2 oxygens here, 1 oxygen here. You can only place the number in front, and you know right away the zincs are now off because that 2 will go to that and to that. So now I have 2 Zns here and only 1, so I'll put a 2 in front, and my friends, you're done. Yes, they can be this quick and easy. And yes, I put some of these on your assessment. Yes, you can do this. Practice, practice, practice. Number 4. What do I... Okay, hey, on number 4, I want you to go as fast as you can. I'll tell you right now, I'm going to use chlorine and sodium, so you can already begin to locate chlorine and sodium on your table. Let's get this done as fast as possible. Pick up the pace and let's check this one out. Number 4 for today. Okay, here you go. Let's take chlorine plus sodium. Okay, there's your two reactants. What are you going to make? You're going to make your French fry salt. Bam. Okay, come on. Be careful. Look at these things. Change to symbols and formulas. Get this thing balanced and go. Let's see what you got. Chlorine, symbol, Cl, and bam. I pause right there because something doesn't look right. Is chlorine alone? Yes. Is chlorine a Hofbrinkel? Yes. There's two yeses. Put a 2 there. Sodium, symbol, Na, and I'm going to pause because something doesn't look right. Is sodium alone? Yes. Is sodium, Na, is it a Hofbrinkel? No. Okay, so I know that's correct. Now on the product side, looks like they've combined together into one substance. Time to get some symbols. I don't see amon di tri tetra, so I know that I'm using oxidation numbers. Oxidation numbers, +1, -1. Things are looking good there. So that's the right formula for sodium chloride that you have seen for quite a long time. Now it's balance time. Looks like I have 2 Cl's here. Only have 1 Cl. I can't change how this works, so I can only put a number in front because now I do have 2 Cl's. But now, take a look at this. I've got 2 NAs. Over here, I only have 1. Easy fix. Put a 2 in front. Because now 2 times that does create 2 sodiums on the left. See? Boom, boom, boom. These things can go fast. They can go fast. And hopefully you know what reaction type this is. Single, double, decomp, combustion, or synthesis. Because that is assessment number 1. And that, my friends, is a synthesis. Comes together, produces one thing. Okay, what do I want to do? I want to do, oh yes, okay, we have to do this one because I did place one of these on your assessment. Okay, let's take a look at the 5th one. Number 5. Number 5. Okay, so here we go. Take a look at this. Whoops, I don't know what the heck that is. Take a look at this. C2H2 plus oxygen produces carbon dioxide plus hydrogen oxide. Ooh, I kind of squeeze that in the corner. So here, let me do this. These things are hard to fit. Let me put your second substance over here, which is going to be this. Hydrogen. So if you are writing these in your notes, careful. There are 2 things produced. I had to move it down here so you can actually see it. Okay, the reason why I'm showing you this one is because you do have one of these on assessment number 2. And I want you to look right here. Due to our lovely CDL model, I had to abbreviate your topic number 10. Yeah, you think this was a lot to remember and use? There's a lot more of this that you would have received if you were in person. So I had to cut topic 10 back even more. So what I'm doing for you is you don't know how to name these things or their formulas. And I know that. So I'm telling you right now that acetylene has that formula. Okay, so the first thing you can do, especially when you see that assessment, is you'll see that and you'll go, I don't know what that is. I don't care because that is the formula. So that is what you can start with. Okay, now take these guys apart. Start forming your equation. Check the formulas. Check oxidation numbers if you need to. Look for this di-tri-tetra system to see if it shows up. And then obviously it'll be time to balance this lovely thing. Okay, this might take you a little bit longer. You got a couple things you got to worry about. I'll give you 5 minutes on this one. Come on, you guys can do this. All right, go. Thing out. So that has a formula of that. So I'm going to start with that. Now I'll take it apart. Oxygen symbol. And I'm going to pause because I noticed that this is alone. Yes, oxygen's alone. Is oxygen one of the magnificent 7 Hofbrinkels? And the answer is yes, he's right here. So that forces you to do this. Carbon, oh, there we go. Take a look right here. I see it die. All right, so now I know that I am not using oxidation numbers to get the formula. I have to go back to topic 10 and use the prefix system because I have 2 nonmetals. The prefix tells you the number of atoms that you have. Okay, so I'm going to play the game a little bit differently. Carbon, the symbol is C. I'm going to take care of this part right here. Oxide is oxygen. And then I'm going to look at the prefix that's in front. No, I don't see a prefix like di, tri, tetra. Okay, that means there's only one of them there. Do you have to put the 1? No. I see di. Di should tell you, yes, you have 2 of those there. Okay, that's complete. Now, take a look, watch this. Hydrogen. Oxygen. No, they're not alone, so I don't have to worry about Hofbrinkels. What I'm going to do is use oxidation numbers. You look up hydrogen, there's only one possible positive number. You look up oxygen, there's only one negative option available. Good or bad? Shoot, that's bad. How do you fix that? We're going to drop and cross that thing. We're going to bring that right here. So, my friends, hydrogen oxide is one name you can use for H2O. You've got it. Even though there are 2 nonmetals that share electrons, but we're going to skip that part. Okay, done. I'm going to change this back to a black 2. All right, I'm going to play the balancing game. You should already know the reaction type for this one, this equation. And this, my friends, is combustion. Oxygen, CO2, H2O. There's those 3 guys that are always there for combustion. I know it's combustion. Okay, let's balance this out. I see 2 carbons here. I see only 1 here, so I'll place a 2. I see only 2 hydrogens here. Sure enough, I have 2 over there. Okay, here comes the oxygens, and remember, in combustions, they can be kind of tricky. So I'm going to erase this, I'm going to erase this. Okay, let's check out the oxygens. Looks like I have 2 here for a grand total of 2 on the left. Let's check the total right here. 2 times 2 gives me 4 oxygens. Plus, it looks like there's only 1 here. 4 plus 1 is 5. Okay, here you go. I warned you about this before. You have an even-odd scenario. Even-odd scenario with oxygens in combustions, you have to do the doubling trick. You have to double or times by 2. Why do you times by 2? You need to get this odd number to go away and become even. Any odd number times 2 becomes even. I have got to multiply by 2 and get rid of this odd scenario. So watch this. I'm going to block off of this because that's the only place I'm going to get this thing balanced. And now I am going to multiply by 2. I'm going to multiply this spot by 2, which right now is a 1. Well, you multiply that by 2, you get that. I'm going to multiply that by 2, and 2 times 2 gives me 4. I'm going to multiply this by 2. Well, right now there's nothing there, which really is a 1. And if I times that by 2, that shows up. One thing nice about the doubling trick is your carbons and hydrogens are still balanced. Look, 2 times 2 gives me 4 carbons. 4 carbons. 2 times 2 gives me 4 hydrogens. 2 times 2 is 4. So the C's and H's are still balanced. What I'm interested in are those oxygens. So let's recalculate. Hey, it looks like I've got 2 over here. 4 times 2 is 8. 8 plus 2 is 10, and 10 is an even number. And watch how easy this is going to become. The game is what times 2 can give you 10. At least the math is easy. 5. Those combustions can be a little tricky. If you don't like my doubling trick, you don't have to use it. You can keep going back and forth until you get this combo of numbers, which can only be those numbers. What I mean by that is you can't have a 3 here and a 4 and a 5 and 2. That'll be unbalanced. You could have a 4, 10, 8, and 4, but I don't want to confuse you. All right, my friends, that should take care of assessment number 2. This is our, 10th example problem we have worked together. I think you're ready.